And live. Excellent. We are back live. Anyway, yeah, Mr. Mackey, despite the fact that I've been here for over 12 years and he's been here for like 2, I've gotten phone calls at least once a month for him that, people they look up the wrong name, or I've gotten emails with confidential information where they meant to type in J Mackey, but they put in the JM and picked the first one that popped up because the R kind of looks like a C if you glance at it fast enough. Fun stuff. Anyway, and then the kicker to the whole thing is I'm C205, and you know what his room number is? It's A205. You're kidding me. Jerks. Anyway, welcome back. Let's see. There are 7 people in the chat. For those of you that are in the chat, if you'd be so kind to leave a comment, that'd be wonderful. The first thing I got to talk about is how today is going to be structured. I don't know if your second period teacher is going to talk to you about how lunch is going to go, but have they explained any of the details to you? Cool. I will, because it's very frustrating. But we'll talk about that once I get there. I'll bring it up here. As for the schedule for today, you guys have seen this every which way. You guys received like letters home and emails and whatnot about this, I hope. But basically, yeah. And our class period will be going to 8:43. There's a quote unquote intervention period. That intervention period is meant for your core classes. You guys are not a core class. This is an elective class. That intervention period is not something that we are required to do. The intervention period that they're referring to is like, for example, I teach Algebra 2. And when I teach Algebra 2 for the first 23 minutes or the last 23 minutes or whatever long that thing lasts for, I'm either going to have to be pre-assessing, remediation, enrichment period, post-assessment with those kids, whatever the heck that means. But with you guys, I get to use that extra time for what, actually does matter in this moment, and the fact that we are preparing for an AP exam at some point. So we'll get there when we get there. Obviously, there's going to be opportunities to go back and revisit things. But today, what I really wanted to do was I wanted to focus our attention back on those multiple choice questions that we started last week. But with more time, I want to spend more time with these questions. I have more time in the period. I want more time with the questions. I want to be able to write some things down in our notes, but we'll get there in a little bit. As for today, let's see. You got first period till 8:43. I have to keep that in mind because this time switch is going to mess with me because usually I'm able to keep good time. Then there's the 4-minute passing. Then you go to block 2. You go to block 2 until about 10:10. Then there's a 6-minute passing. Mr. Markey, what's going to happen during that 6-minute passing? Oh, well, I'm glad you asked. Flip my camera over. For those of you that are obviously virtual, this doesn't apply to you, but I want to read this email. Now, you may not be able to see all the details of it, but let me kind of go through this. Here's further information regarding how lunches will be structured. Lunches will take place between periods 2 and 3. They are 40 minutes long and will be grab and go. Period 2 teachers will be required to escort their students to their assigned lunch locations. Here's a link to the locations for each day. Yeah, I'll talk about that in a minute. Please do not ask other teachers to escort your students to lunch. Odd-numbered classrooms will be escorted at 10:10. Even-numbered classrooms will be escorted at 10:13. There will not be a bell for the 10:13 group, but please be prompt. Gym teachers will be responsible for extending the bleachers at the end of period 2 in the gym and gym 2. Outdoor locations, weather permitting, will be open starting Thursday, the 29th. You'll see that tent when you drove in? Yeah, that's fun. When we go outdoors, the group will be divided into 2, half indoors, half outdoors. Now, hold on. Oh, yeah, I got that. When we do go outdoors, meaning starting on the 29th, the groups, the pre-mentioned groups, which are your lunch locations, will be half indoor, half outdoor. I'll show you the locations in a little bit. Duty personnel will be divided for supervision at that point. Teachers on lunch duty, thankfully I'm not, have to get a walkie-talkie. Students are to spread out to the best of their ability and are not allowed to walk around. When they are done eating, their mask needs to go back on. Students are not allowed to line up at the door at the end and will instead be dismissed. They are responsible for cleaning up after themselves. The only bathrooms open during lunch duty are E-hall and cafeteria bathroom. The concession stand bathrooms will be opened when the students are at the football field. Yes, the football field is one of the locations where you could potentially be eating lunch. I'll talk about that. I know, this is great. E-hall bathroom will be utilized by the tent location. Please write up any students walking around during lunch. That's my favorite line right there. Students are not allowed to switch between locations during lunch, and administration will review all of the lunch rules with students on the first day. Oh my gosh. Let's take a look at these locations. Some of the locations. Let's see here. This is weird. Make that bigger. There we go. This is A day. Okay, yeah. The reason why they broke this up, A day and B day, you can see orange and black day, is because each day you have a different second period teacher. And because you have a different second period teacher, you could be eating lunch in a different location each day. So I don't have a second period on A days, but I do have a second period on B days. I'll show you that. So you have the cafeteria and the tent. You have Gym 1 and the football bleachers. Keep in mind, the outdoor locations are not open today. You have Gym 2 and Courtyard 1. I guess that's where the koi pond is, I think. I hope, whatever. Then you have the library and Courtyard 2. I don't know where Courtyard 2 is. I assumed that Courtyard 2 was right here, outside the window. Yeah. They had a bunch of picnic tables in there last week, and now they're gone. Where the heck is Courtyard 2? I'm not really sure. So then on B days, it's the same thing, except you have different teachers. Like, for example, there I am right there. I have to bring my 6 students down to the library today. But on A days, those 6 students, I don't know where they're going. It depends on who their teacher is. So, for example, it's like, oh, I guess I have to find my second period teacher and then do that, I guess. I don't know. I'm not going to do this for everybody, but just name a second period teacher that you have. Geddes. Okay. Let's see. Geddes. Oh, there he is. So if you have Geddes today, you will be eating lunch in Gym 2. Yeah.
Wait, are all of those students in Gym 2?
Wait. All of those students.
Or is it like split for that and Courtyard?
Oh, Courtyard's not open today.
Oh.
Yeah.
That's kind of a lot.
I have no clue. Yeah. The question, just in case you didn't hear, it's like, so like Gym 2 Courtyard, according to the instructions, it said that they would be split between the two. I have no earthly idea how they are going to determine splitting those students between the two locations. I have no idea. I have no stinking clue. We got most of these emails about like lunch and remediation, all this stuff. We got these emails like on Friday when we're getting ready to leave. It's like, do you think we bothered to read any of them? Kidding me. So that's what you have in store for during at the end of second period. So yeah, it's going to be a train wreck. I'm going to bring down my students, my 6 students. All right, guys, have fun. And I will leave, and I will not turn around. Goodness gracious. Anyway, back to what we're doing here. Sorry for those of you online who had to hear that whole spiel. Obviously, if you're online, it doesn't matter. You don't have to deal with lunches. So good for you. Anyhow, so you have due tomorrow a couple of assessments for me. You have a minor assessment on quizzes that you have 2 attempts to get done. And then you have a major assessment. I'm just taking a peek at them right now, at the ones that have been turned in so far. You have a major assessment also due tomorrow. Now, keep in mind, being that they're due tomorrow, when I assigned them originally on Thursday, it says that I posted this on the 22nd. So yes, that is Thursday, as I said I would. And I wanted it to be due Tuesday because I wanted to be like, hey guys, reminder, this is due tomorrow. So, but it is due at 7:30. So please make sure that you are prompt with that. The quiz's code will expire at 7:30. You do have 2 attempts, so please, I'm only going to take the highest of the 2. So we're going to figure that junk out. And of course, if you have any questions, you can always email me. That'd be great. Anyway, as I want to do, I can't even talk today. As I said earlier, I wanted to work on some multiple choice questions, but I wanted to work on them slightly differently than what we've done in the past. In the past, I've wanted to do these multiple choice questions. I wanted to give you no more than a couple of minutes, and I wanted you to very quickly show your answer and kind of do that thing up. What I want to do today, I want to put into our notebooks. Now, yes, you'll still be choosing an answer, but you're not going to be holding it up for me today. Instead, after I reveal said true answer to the question, I want to spend some time with that multiple choice question, and dissect it to see what exactly is expected of us. So if you do not already have them open, I'm going to need those notebooks out and open. Woo! Let's see here. Yep. And then this one. Nope. Oh yeah, that's a good. Okay. So for some of these questions, obviously, there's not really much in terms of calculations. But what I want to do first is I do want to revisit one of the questions that we did last Thursday to kind of talk about some of those details. I'll show you what I would write down for them after I kind of bring this up and remind you as to what this problem was about. It'll focus in a moment. Come on. Focus. There it is. Good. So we've done this question, but I wanted to revisit some of the math that was behind it because of the nature of this thing being double-sided. It says a fitness center advertised that the average pulse rate of its members is 68.4. That's what it advertises. That's what it claims. That is the overarching assumed population parameter because innocent until proven guilty. A high school AP stat instructor suspects that this is a made-up number and runs a hypothesis test on a simple random sample of 48 members, calculating a mean of 71 beats per minute, standard deviation 10.3. Those numbers, that's 71 and that 10.3, they are sample statistics, so we will give them the appropriate notation. In which of the following intervals is the p-value located? Now, when we did this question on Thursday, a good portion of you got it right, and a good portion of you got it wrong only because you had the wrong alternate hypothesis. You had the wrong alternate hypothesis. That is the only reason why you got it wrong. The fact that the high school AP instructor suspects that this is a made-up number does not indicate that he's saying that it should be more or it should be less. He's just saying it should be not that number. It should be not 68.4, which is why the alternate hypothesis should be not equal to. Now I'm going to write down a couple pieces of information here about this particular problem. Let's see here. I'm going to have to zoom back out. Let's see, zoom out. There we go. So I'm going to call this multiple choice review. And today is the 26th. For those who care, it's my daughter's birthday. Okay, nobody cares. All right. 3. She is now 3 years old. You guys ever watch Octonauts? Cool. No? Okay, several people nodded yes, and I immediately, you were like, I'm like, okay. In Octonauts, there's a character named Quasi. He is an orange cat, and my son has always identified with Quasi when he watched that show when he was that age. He was just always like, I'm Quasi, blah, blah, blah. And we're like, yeah, that totally fits his personality, like perfectly. For those of you who know about Octonauts, my daughter has fallen in love with Octonauts, and she has immediately identified with the character of Tweak. I don't know. She's the mechanic engineer. I think that's, I'm like, okay, she woke up this morning, and I'm like, happy birthday. She's like, I dreamed about Tweak. I'm like, all right, cool beans. Back to this. So a couple pieces of information about number 10. This is multiple choice number 10 about the fitness center. The claim is a mean of 68.4, and notice I put mu equals. That's the claim. There is a sample mean of 71.0 and a sample standard deviation of 10.3. And again, notice the notation that I'm using to identify these things. Now, the beauty of multiple choice questions is also the terribleness of multiple choice questions. The beauty of multiple choice questions is that you really don't have to write anything down. You solve the question. The only thing you have to give is the answer, and that's what they'll judge you. That's what they'll judge you on. But that's also the terribleness of multiple choice questions. Because as I saw on Thursday, a lot of you could have gotten this question right if only you had changed that alternate hypothesis to be the other symbol. But it's either right or it's wrong. And that's multiple choice math. Okay. So we don't have to actually go through the full steps of hypothesis testing for assumptions and conditions, simply because, well, number one, they don't ask us to. And number two, all of the answers, as we saw right here, all of the answers are going to be a p-value between a couple, certain values. We'll see what happens. But I do want to write out our null and our alternate, and I want to compare it to what would happen by changing that alternate hypothesis. According to the context of the problem, it should be not equal to. So let me bring this up. I have my calculator ready to go right here. Oh, which, by the way, I haven't even talked about this yet. I mean, I did on Thursday, but what the heck test are we going to use here? We have to figure out what test we're going to use, because obviously that's going to play a huge role in what p-value we get. We have quantitative data, means, and this is all the information that they gave us. I mean, yes, they did tell us n equals 48, but what are we going to use here? There it is. I don't know how many times I wrote down the chart, but I got to find out. Oh, there's one example of it. I wrote this down last on probably March 22nd. This is one of my sets of notes right here. I'm going to zoom in. But what type of test are you going to use? Well, do you have categorical? Do you have quantitative? We have quantitative. Okay, next question. Do you have the population standard deviation? No, we don't have the population standard deviation. Then you got to use a t-test. This is the flow chart. This is a very generic flow chart. But this does make a huge difference as to what type of test you're going to use. We have to do a t-test. This is a one sample t-test that we have to use. Come on, paper, go back in there. Get in there. There we go. I'm going to be doing a one sample t-test. Mainly because we don't have a population standard deviation. T-test. I'll go over to stats. Mu is 68.4. Sample 71. Standard deviation 10.3. And it's 48. And there's the alternate. Now, I am going to write down the correct answer, but I wanted to compare it against what the other ones did. So the correct answer that we should be getting here, and you know what? I'm actually going to draw it just so you can visually see something. We should be getting a p-value, and it's in the bottom right corner, a p-value of 0.0868. We should be getting a p-value of 0.0868. Now, because we did not equals 2, that implies that they're going to be basically doubling what we typically get for a p-value. Because they're doing not equals 2, they're actually checking both sides of the chances of being greater than the 68.4 or less than the 68.4 because it's not equal to. Now, let me compare that to this. If I reran that t-test, but I changed it to greater than. Now, Ms. Ranke, why would you change it to greater than? Well, because the sample was greater than the claim. The sample was greater than the claim. Okay. So if I ran that with the sample being greater than the claim, redraw this thing, it only fills in half of what they had before. In fact, half of the p-value that is of what we wrote down. We wrote down 0.0868. But a lot of you got 0.0434 because you said, oh, it was just greater than, which implies the wrong answer. Flip back to here, zooming in, zooming in, zooming in, zooming in. It all comes back to the context of the problem. A lot of you picked C. A lot of you picked C. That's probably about a third of you picked C. But the correct answer was D. And it was because the alternate hypothesis had to be not equal to. It all comes down to what the AP statistics instructor said. Stat instructor suspects it's a made-up number. Did not specify a direction. Did not specify a direction. We have to be very careful with that. Oh, these questions. Okay. The next one we did was 12. You know what? I am going to write that one down. Although it doesn't require calculations. Let me bring this one up. Zooming in, zooming in, zooming in, zooming in, zooming in. Here we go, to remind you of what the heck is going on here. Come on, focus. There it goes. In a one-sided hypothesis test for the mean, a random sample of 15, wait, I'm reading that way off. For a random sample of size 15, there we go, nailed it on the third try, great. The t-score of the sample mean was 2.615. Is this significant at the 5% level or at the 1% level? So let me write down a couple pieces of information here. This is number 12. I'm going to call it, is it significant? Is it significant? We have a t-score of 2.615. They don't give us any other pieces of information. They don't give us sample sizes. They don't give us sample means or sample standard deviations. They don't give us anything. The only thing they give us is the t-score. That is okay, because we can calculate a p-value. In order to determine whether or not it is significant, we have to look at the p-value. And this is what you're going to have to calculate. TCDF, it does say one-sided, 2.615, comma, big number. Do they not give us, oh, sample size. They give us a sample size of 15. They did give us that. Sample size of 15. What do I put there? Technically, you don't have to memorize it because the calculator will tell you what you're going to put there. But does anyone remember what you're supposed to put there? Degrees of freedom, patriotic, statistic, etc., etc. You put a 14 there because n equals 15. The calculator will remind you of that. The calculator will remind you of that. I'll show you where on the calculator it kind of reminds you. But you do have to recognize that degrees of freedom go there. They did give you that piece of information. That's cool. Click. Let's see. TCDF, as a reminder, is where normal CDF is, second vars. TCDF should definitely be there. Even on a regular TI-83 calculator, it's still there. But it doesn't give you the same interface. Oh, yeah, that's right. They haven't told me how you guys are going to be handling calculators yet. Have they told you anything? Great. Fantastic. I'm so excited because you've been training on these calculators all year, and then all of a sudden for the test, I'm going to give you some rinky-dink TI-83s. I'm so excited. I'm going to talk to guidance about that just because I'm like, we need to figure something out. Anyway, 2.615, boom, giant number, doesn't matter what it is. Degrees of freedom, America. Paste it. There's my P value, 0.0102. I'll write that down, 0.0102 for a P value. Now, the question is it significant? If the P is low, the hoe must go. That is my P value. It is significant at 5% because 0.0102 is less than 0.05. It is significant at the 5% level because it's less than 0.05. It is not significant at the 1% level because 0.0102 is greater than 0.01. It's significant if you have to reject the null hypothesis or if you end up rejecting the null hypothesis. So I just wanted to make sure we wrote that down because there was the wording on this question was just so typical of the way that they word questions just because they want to screw you up. They want to screw you up. These questions. Okay. I'm going to give you a moment to try a new question. I'm going to give you a moment to try a new question. And again, you don't have to write it down on a dry erase board, but I would like you to write it down into your notes just so you can see for yourself, like, oh, I picked this answer. Oh, crap, I was wrong. Or, oh, yeah, I was right. And then you could either draw a happy face or a sad face. Zooming in, zooming in, zooming in, zooming in, zooming in. When making an inference about a population mean, which of the following suggests the use of z-scores rather than t-scores? And I'll give you about 30 seconds. Okay. Now, like I said, I said 30 seconds mainly because it should take roughly 10 to 15 seconds to read the question. And then hopefully once you have read all the choices, I mean, that's including the choices, 10 to 15 seconds to read everything on the card. And then hopefully after that, you should be able to come to a quick and swift decision. You'd be surprised at how many people get this one wrong just because they rush it. But again, we're trying to save time. One answer that people typically try to pick is the sample size under 30 part. But this would be, it's one of the assumptions and conditions that the sample size has to be large enough, but that's a large enough condition for z-scores. But this is saying under 30. Again, people would rush through this and their mind would fill in the blank with the word under rather than over. The population is normal. That's a big one. That's a big statement right there. I mean, obviously for z-scores, I mean, we're hoping that the population is normal. I mean, obviously z itself is implying it's normal. And then for t-scores, there's a nearly normal condition. But again, that doesn't apply here. Got to read through everything. Outliers are absent. You can have outliers in anything. That has nothing to do with anything. Strong skew is absent. Strong skew is absent. I mean, again, we'd prefer it to be more normal looking, normal enough. But again, that doesn't really apply. The answer is E. The population standard deviation is known. The population, I'll flip over the card. There we go. Zooming back. There we go. In the presence of strong skewness or outliers, the T procedures are, what's it say? That's not contradicted. What is that? Is that contraindicted? Am I wrong there? Contraindicated? I'm going to Google this. Hold on a second. This is bugging me. Hold on. Contraindicated, like that? Suggest or indicate that should not be in the case of what? I hate the English language. What?
What does that mean?
What does that mean? I know what contradicted means. But the point that you're saying, though, when you read it out, it should not be used in the case in question?
In the case of this particular problem, we should not be using that.
Oh, my word. I've never seen that word in my life. Usually because I don't read the back of the card that much. I just like, oh, I got it right. Moving on. You know.
Every single back of the card is going to have that word.
I know, it will. It's going to bug me. But anyway, the T procedures assume normality of the original population. When the population standard deviation is unknown, the standard error is substituted for sigma over square root of n. Then t-scores rather than z-scores are the proper choice. However, in those, now I want to emphasize this, rare cases when the population standard deviation is positively known, z-scores are appropriate. It is rare in real life that you will know the population standard deviation sigma. Very rare. Most of the time, it's like questions that said, oh, assume that sigma is equal to this, or assume the population standard deviation is this. Then you could do it. But regardless, when should you use z over t? When, well, both could happen. Population standard deviation. That's why I made that flow chart for you. I'm not going to write anything down for that simply because that word bugs me. Here's a new one. Again, one of these are the types of questions that should take you like 30 seconds. But under what conditions would it be meaningful to construct a confidence interval estimate when the data consist of the entire population? Take a moment, read it through, write down what you think the answer is. You're not going to show it to anybody, but you write down what you think it is. Hopefully, you remember what I said when I told you that the people who make this test They hate you. They hate you and everything about you. They want you to fail this test. They do. They absolutely do. What is the purpose of a confidence interval? What is a confidence interval attempting to do? When you interpret confidence intervals, what do you say about them? True answer or true population. Yeah. You're hoping, you're saying like, I'm 95% confident that the true mean is within this interval. Not 100%, but that's what I'm trying to do. I am attempting to capture the true mean. That's what a confidence interval does. Here's a sample. I can construct a confidence interval. I'm hoping the mean is in there. But the data consists of the entire population. If you have the entire population, also known as a what? A census. If you have the entire population, you don't have to capture the true population mean. Because if you have the entire population in your data, guess what? You have it already. The answer is never. The answer is never. In determining confidence intervals, one uses sample statistics to estimate population parameters. That's the attempt at capturing them, capturing the population parameter. If the data are actually the entire population, well, then making an estimate, there's no point to it. This is an amazing trolling question. This is one of those questions where it's like once it's explained to you, you're like, well, that makes sense. But then when you read it, imagine reading this question after 89 minutes on the multiple choice section of the test. You're like, crap, I have a minute to go. And you're just trying to make your best educated guess. And then the only thing that pops into your head is what somebody told you in middle school. Choose C. I don't know when you guys were told that. Somebody once told, I legitimately had a conversation with somebody once where a few years ago where they tried to defend the picking C argument. And they're like, pick C. And I'm like, that's such a dumb argument. Why would, and they're like, no, Ms. Markey, it works. It works. It works like 25% of the time. I'm like, what if there are 5 options? It was hilarious. Oh my gosh. Anyway, back to this. I want to show you a video. But hold on. Let me actually freeze the screen so I can get this video rather well just discreetly. Let's see. Hold on. Just because I want to show you this thing. There it is. Hold on. Yes, I think this is it. Okay. I might have to change the volume real quick because I don't want the blast.
I just took my.
There it is. Okay. This is dumb, but it is incredibly helpful. It is incredibly helpful if you understand truly what they're talking about. So I have the microphone with the speakers right here. Listen very carefully to their conversation.
AP statistics.
Oh,
I just took my AP statistics test.
How do you think you did?
Well, I wrote that the population was the 27 textbooks in the sample.
Don't you mean that the population was all such textbooks?
Well, no. I said the 27 textbooks that were actually examined make up the population.
You fool. That's wrong. You just lost points.
Well, I made sure that I remembered to put X bar in the null hypothesis.
You mean mu? You wrote mu in the null hypothesis, right?
No, I just told you that I put X bar in the null hypothesis.
You fool. That's wrong. You just lost points.
I wrote a list of all the conditions and assumptions that were supposed to be met. I remembered to do that.
That's good. Did you show all the conditions being checked, or did you just write that list?
I wrote the list, put a check mark next to each one, and then just said that all the conditions were met.
You fool. That's wrong. You just lost points.
Well, I did graph the data that was given in the problem.
Then I assume that you explained what the graph indicated about the problem in context and explicitly referred to the graph in your discussion, right?
Nah, that would take too much time and effort. I just sketched the graph and figured that the reader or grader would understand the relationship to the problem.
You fool. That's wrong. You just lost points.
Well, I wrote that the test statistic was t equals x bar minus mu all over s, and so I guess that is good that I wrote the formula.
Did you put the s in the denominator over a square root of n?
No, I just wrote the s down there. That sample size, n, doesn't matter, right?
You fool. That's wrong. You just lost points.
After I wrote the test statistic formula for t, I made sure that I wrote out all the calculator steps and buttons that I pushed, and then I copied down exactly what I saw on my calculator screen.
Did you show all the numbers plugged into the formula?
No, I just had the formula. And then, like I said, I wrote all the buttons I pushed, and all the stuff that I saw on my calculator screen.
You fool. That's wrong. You just lost points.
Well, I knew enough about the problem to use a normal distribution for the distribution of my test statistic, the t statistic.
So, you wrote that the distribution was approximately normal.
No, I said it was a normal distribution. I didn't use the word approximately. I just wrote normal.
You didn't say it was approximate. You said the distribution was normal, thereby implying that it was exactly normal.
Yes, I said it was a normal distribution.
You fool. That's wrong. You just lost points.
Yes. Well, after saying it was normal, I then continued with my hypothesis test about the mean.
Wait, you said the distribution of t was normal.
Yes. After all, every test statistic follows a normal distribution, right?
No, actually, only a z statistic follows a normal distribution. Your t statistic follows a t distribution. They are two different distributions.
Oh, well, they're close enough. After all, they are both symmetric and bell-shaped. They should be interchangeable.
You fool. That's wrong. You just lost points.
Well, anyway, I got my p-value, and it was 9.2, so I wrote that as my p-value.
You wrote that the p-value was 9.2? Didn't the calculator have an e, followed by some negative number after that?
Oh, right. It did. It had 9.2 e, and then negative 4, but I figured that the e meant that was something extra, or that there was an error. So, I just wrote that the p-value was 9.2.
That e means that the calculator has changed to scientific notation. Your p-value was very small. In fact, it was 0.00092.
Oh well. It's all the same thing.
You fool. That's wrong. You just lost points.
Well, since I thought the p-value was really big, I figured that we should not reject the null.
So, you mean that you wrote that you would fail to reject the null hypothesis? That's great that you have that decision following directly from the large number you thought was the p-value.
Well, no. I didn't exactly say to fail to reject the null. I said that I accepted the null.
You fool. That's wrong. You just lost points.
I also said that there was a 9.2% probability that my null hypothesis was correct. There was a 9.2% chance that the mean was as stated in my hypothesis. I suppose that gave my conclusion and an interpretation of my p-value.
Your interpretation of the p-value is flawed. A p-value tells us the probability of seeing these results, or even more extreme, assuming that the null hypothesis is true. It is a conditional probability.
That's the same thing. Whatever.
Likewise, your conclusion was not really in context. A statement about the mean in the null hypothesis could be made about any such hypothesis. There is nothing specific about the problem in your conclusion.
Well, I talked about the mean. That should be an
You fool. That's wrong. You just lost points.
Well, I think I did okay overall.
You'll be lucky to get any score at all. I wouldn't be surprised if your score ended up being a negative number. You showed poor statistical practice over and over again. The academic community frowns upon your complete ignorant foolishness. Goodbye.
Yeah. That was fun. Well, fun for me. I don't know. Let me go back to this real quick. How did that do? I found that video a few years ago, and I don't know why. Every time I watch it, it just always makes me like, wow. Believe it or not, every year people do that kind of stuff. They spend all year in a stat class, and then they get to the test, and I'm not saying that you're not allowed to make a small mistake. Like, yes, of course, you make small mistakes all the time. That's not a big deal. But like, there are people who like do an entire hypothesis test as described by, what was that? Was that a pig? Was the other one a dog? All right, whatever. I don't know. You fool. Anyway, next question. Boom. This one you will have to do a little. Oh, I can't see it. You may have to do a little calculation for, but let's. Oh, it's frozen like my heart. There we go. Zooming out. A quality inspector plans to test a sample of 40 bottles of soft drink labeled as 20 ounces. If she finds the mean content to be less than 19.8 ounces, I'm sorry, the mean content. I didn't mean content. I hate English. She will have the bottling machinery stopped and recalibrated. If it is known that the machine operates with a standard deviation of 0.75 ounces, what is the probability that the inspector will mistakenly stop a machine that is delivering a mean of at least 20 ounces per bottle? Now, this question has a lot of nuance to it. It has a lot of nuance to it. I'm going to leave you be with it for a couple of minutes to think about what the heck is expected of you on this problem. Reread it if need be. But I want you to treat this like this is an actual AP test question. Go. This is the type of multiple choice question that either you're going to read through it, you're just going to try to brute force something real quick, and just, oh, one of my answer matched something here, yay, and then you move on. But we really have to dig a little bit more to this. There's a few things that we have to dissect. Now, I'm not giving away the answer just yet. I am not giving away the answer just yet. So if you're still working on it, please do so. But there's a few things that I want to point out. The quality inspector plans to test a sample of 40 bottles. So we got an N value of 40. Cool. Of a soft drink labeled as 20 ounces. Now, it's making the claim of 20 ounces. It's not saying that the sample was already taken, but let's just see what happens. If she finds the mean content to be less than 19.8, she will have the machinery stopped and recalibrated. That implies to me that if she runs a hypothesis test and she ends up rejecting the null hypothesis, she will have the bottling machinery stopped and recalibrated, meaning my alternate is probably going to be with a less than symbol. If it is known that the machine operates with a standard deviation of 0.75 ounces, now that's an interesting statement. They're talking about a known standard deviation. That has nothing to do with a sample. They are implying a population standard deviation. Then they ask, what is the probability that the inspector will mistakenly stop a machine that is delivering a mean of at least 20 ounces per bottle? Now that last question throws everything into disarray. Because in the beginning of the problem, you can pick out certain pieces of information, the sample size, the null, the population standard deviation. You have all of this stuff floating around. But then that question deserves a bit of focus. Hold on, let me read it again. What is the probability that the inspector will mistakenly stop a machine that is delivering a mean of at least 20 ounces per bottle? What is that question really asking? Yeah, that's what it's really asking. That question is really asking, what is the probability of, well, if I reject the null hypothesis, then I'm going to stop the machine and recalibrate it. But if that's a mistake, if you reject the null, stop the machine, but you're wrong, that's a type 1 error. You reject the parachute, but you still live. That's a type 1 error. Now, typically, a type 1 error, the chance of making one is alpha, 0.05, which, believe it or not, again, a trolling move, a very trolling move, is the fact that they have 0.05 as one of their options. But we assume that alpha is 0.05 just based on some generic threshold or standard of rejecting or failing to reject. That's not really what they want here. That statement, if she finds the mean content to be less than 19.8, let me flip over the card and then we're going to write some stuff down. Let me flip over the card. We're going to write some stuff down. Boom. The answer is B. Now, I'm going to write not all of this stuff down, but I wanted to point some stuff out. We have a null at mu equal 20 and an alternate of being less than 20. Those things can be deciphered from reading through the question. Look right here. Sigma 0.75. They have a population standard deviation of sigma at 0.75. Now, yes, they do divide it by square root of 40 to get that. They're actually calculating the z-score. We're not going to go that far. We're not going to go that far to actually calculate a z-score. I'm going to show you what you would actually write down for that. But then eventually they ran a normal CDF. They did that because you had the population standard deviation. It's a z-score. And then ultimately you get that p-value at 0.046. There is a 0.046 probability of committing that type 1 error and mistakenly stopping a machine that is delivering the labeled 20 ounces per bottle. Now, I want to explain how that all ties in. Let's write down some information, and then I'm going to go back to the wording of the question. Zooming out, zooming out. So this is number 28. Bottling. If I can spell bottling today, I'll try it again. What was that word again? Contraindicated? Gosh, silly English language. Bottling and type 1 errors. I recently discovered this guy on YouTube that does like short videos talking about like the English language versus the French language and the Spanish language. I can't remember his name, but it's hilarious. Have you ever seen videos by this guy? All right, if you have, it's fantastic. It's just, they're short, like 40-second videos, but just talking about like how stupid language is. Math is better. Anyway, mu is equal to 20. Sigma is equal to 0.75. N is equal to 40. X bar is equal to 19.8. Now, if I throw that all in to a one sample z-test, if I throw that all into a one sample z-test, and I will show you on my calculator right here. Let's see, do z-test, mu at 20, 0.75, 19.8. Sample size of 40. Oh, I would do less than. Based on, actually, I'll flip back to my paper real quick. Boom. I would do a null hypothesis of mu equal 20 and an alternate hypothesis of mu less than 20 because that's what the problem indicates. If you go back to the problem, it says that if she finds the mean content to be less than 19.8 ounces, she will have the bottling machinery stopped and recalibrated. Now, if I run this test and calculate this sucker, boom, I get a p-value. I'll show you what I'm writing down in a moment, but of 0.046. 0.046. That is the p-value that is calculated. Again, multiple choice question. Since it is a multiple choice question, you don't have to worry about writing any information down for the person to grade you. They're just going to. That's not us. They never took off the bells for 820. Or they're actually indicating that this should be the beginning of the remediation period. If they do, I think that that's the stupidest thing in the world. Just let the teachers do their job rather than interrupting them with a bell. But back to this. I hope there are people walking through the hallway. Anyway, p-value of 0.046. Now, if we had a p-value of 0.046, you would think normally, well, it's like, well, if we had a p-value of 0.046, then we would reject that null hypothesis. We would say, we reject the null hypothesis and...
Just a reminder, that was not the dismissal bell. We should be going to 8:43. We will silence the bells and try and reprogram them.
You should have thought about that last week. No, they haven't. This is literally like the email I showed you, literally like Friday. Yeah, literally Friday. We got that on Friday. They were in meetings pretty much all Friday. We got emails at like 3 and 4 o'clock on Friday afternoon. Yeah. Anyway, back to this. I'm going to recalibrate my brain. I get a p-value of 0.046. We would reject this null hypothesis. But again, that's not what the question's asking. If we reject this null hypothesis at 0.05, then yeah, we would say there's a 5% chance we made a type 1 error. But that's not what the question is asking. It's not saying, oh, what are the, that we're rejecting this 20 ounces. If we go back to the actual wording of the question, zooming in, zooming in, zooming in, zooming in, zooming out. There we go. If she finds the mean content to be less than 19.8 ounces, she will have the bottling machinery stopped and recalibrated. Now, that 0.046, which is the answer that we got, this is the answer that we got right here. We're saying that there is a 4.6% chance of seeing 19.8 ounces, I guess you could say, or less in this case, because you're doing less than. But there's a 4.6% chance of seeing 19.8 ounces or less, meaning there is a 4.6% chance that you will make a mistake. 4.6% chance of making a type 1 error. It's a trolling question. Because first, you have to understand that they're talking about a type 1 error. And then number two, realize that they're not just assuming 0.05. There was no assumed alpha level. You can put the alpha level at whatever the heck you want it to be. And in this case, she put the alpha level at 0.046, indicating a 4.6% chance of making a type 1 error. This is an amazing question. I love it so much. So let me write down some more information in regards to it. Zoom out. So I'm going to write down first what we know to be true. 4.6% chance of seeing X bar equal to 19.8 or less, assuming mu equals 20 is true. I'm going to repeat that. There's a 4.6% chance of seeing those sampled results, assuming that the mu equals 20 is true. The question specifically said, if she finds the mean content to be less than 19.8 ounces, she will have the bottling machinery stopped and recalibrated. So what are the chances, or what is the probability that the inspector will mistakenly stop the machine that is delivering a mean of at least 20 ounces per bottle? Well, it's a 4.6% chance. Yay. Oh, these questions. See what other, they didn't really give much else in terms of that, but I like that. I'm going to share with you what my wife just sent me, just because I find it hilarious. I told you it's my daughter's birthday. So my wife texts me. I just gave her her birthday donut because, I don't know, Dunkin' Donuts does birthday donuts, I guess. Whatever, I don't care. Whatever. And my 3-year-old said in the creepiest voice, "I'm going to eat you." Like, that's amazing. Just amazing. Anyway, I wish I could be there. But I'm stuck with all of you. Anyway, back to this. Oh, goodness gracious. Why do they let me do this job? Here we go. You know what the funniest type of laughing in the world is when people just let air just out their nose briefly? Which several of you just did. Anyway, that's the type of comedian I want to be, where people just breathe slightly. Okay, it'll focus in a moment. Okay, lots of reading. Let's see what happens. A police department public relations spokesperson claims that the mean response time to a 911 call is 9 minutes. A newspaper reporter suspects that the response time is actually longer and runs a test by examining the records of a random sample of 64 such calls. What conclusion is reached if the sample mean is 9.55 minutes with a standard deviation of 3 minutes? Take a minute or so. Let's see what you can do. I don't think there's anyone out there. If there is, then I don't know. There's never, you guys ever see anybody on hall duty? Like, yeah. But don't walk during lunch. She got caught by security. Okay. I wrote down some information, which I'll share with you in a moment, but I just wanted to talk about a couple pieces here. First of all, the 9 minutes is the claim. That's the mu. The sample, X bar is 9.55, S is 3, and N is 64. And the alternate hypothesis, the newspaper reporter suspects that the response time is actually longer, meaning that the alternate hypothesis should be greater than. These are all pieces of information that you should pull out. But then, for these questions, we've been going back and forth between either T or Z. We've been going back and forth between T and Z. Please be very careful when you're actually doing this. I got to unfreeze it. Boom, there we go. That's what I wrote down. But you really should be focusing for this one on a t-test. You really should be focusing on a t-test for this particular problem. That is what is needed. But of course, once you get that t value, or I'm sorry, that p value from the test, you do have to indicate an appropriate answer. Let's see what happens here. So I'm going to do a t-test with all of this information. Let me flip my screen over to the calculator. Clear that out. Stat tests t mu is 9, 9.55. S is 3. 64 is my sample size, and I already indicated that the alternate should be greater than. Calculate that sucker. Boom. Get a p-value of 0.074. 0.074 or some junk like that. which is great because then it's like, oh, 0.074. Oh, the p-value 0.07, indicating some evidence against the 9-minute claim. I want to talk about that. I'm going to flip back to the screen real quick. That's what I wrote down, by the way, 0.074. But now let me actually go to the choices here. On the choices, I want to talk about this whole idea of like there being, quote, some evidence against. If you read C, choice C, the p-value is 0.07, which is the answer that we should get. And it is correct. C is correct, indicating some evidence against the 9-minute claim. Some minute evidence against it? What do you mean? But 0.07 is not less than 0.05? Well, yeah, it's not. You would fail to reject at 5%. You would definitely fail to reject at 5% if that were your alpha level, but you would reject at 10%. And again, this is what I was talking about the other day. I think we got like a p-value of like 0.058 or some junk like that. And I was trying to show you the consequences of rejecting and failing to reject. Like what could potentially go wrong? What mistakes could you make? What conclusion should you come to? Well, there's some evidence against that 9-minute claim. There's some evidence that you can reject that 9 minutes. But perhaps in your conclusion, you would say there is not enough evidence. So, I mean, if it were me and I actually had to write out a conclusion, I would say, well, since 0.07 is greater than 0.05, I fail to reject the null hypothesis. There is not enough evidence, implying that there is some evidence against the 9-minute claim. But yeah, the answer is C. I have one more question, but I want to give a little monologue speech because I'm going to give a lot of these. It's going to be great. I talked last week about your AP test. Tuesday, there it is. Tuesday, May 25th, which is an A day. You have your test at noon. Hopefully you took the opportunity to fill out that Google form for transportation. We'll figure that junk out. But basically, you're going to show up at 11:30 in this trailer. Hilarious. And then you're going to be taking your test sometime around noon. You should be starting that test. They have to go through all of the original, spiel speech, the instructions and blah, 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 blah. But then you're actually taking the test. 90 minutes. 90 straight minutes. No breaks on the first part, whatever that is, whether it's the multiple choice or the free response, but 90 straight minutes. Then you get like a short break. I don't really know how long the break is. I think the break is like 5 to 10 minutes or some junk like that. But then you have 90 more straight minutes with the other half of the test. No breaks. It's a marathon. For those of you that have taken AP tests before, you kind of understand what this feels like. It can be torture to an extent to be like done with your test at 70 minutes and then have to sit there for 20 minutes. And then some people just like, well, I'm just going to go to sleep. Did I tell you about the kid that took one for the team the other year? Yeah. Ridiculous. What a legend. I know. Like he just, for those of you who don't remember, he literally announced to everyone else, I'm taking one for the team. And he didn't even bother taking the test. He just sat there for 3 hours. Yeah. He came to the test and then didn't take it. I'm sorry. Why would you do that to yourself? But he said he was taking one for the team. Okay, cool, dude. Hope you do. Oh, the way that it works is let's pretend that there's 200,000 people taking the test on one day. If there's 200,000 people taking the test on one day, approximately, the number shifts from year to year, but approximately the top 60% pass and the bottom 40% fail, meaning you're just trying to outscore 40%. So he was just basically saying, Take one for the team. I'll be in the bottom 40. My gosh. It's a marathon, not a sprint. You cannot just rush through these questions. I mean, yes, you go through them swiftly and you want to be strategic and you want to have enough time at the end to be able to go back and check your work and check your answers and look at the problems that you think need to be revisited. These are strategies that we can employ, but you got to know 90 straight minutes of just sitting there. It's either, for you, it's going to feel like one of two things, and it's not going to be in the middle. It's either going to feel like, oh my gosh, we're only like 10 minutes in, I can't do this. Or it's going to feel like, holy crap, I only have 5 minutes left. How did this time fly by? And it's not going to be because it was fun. Just say. It's going to be one of those two things. 90 straight minutes. See, the thing is, in class, like we've been in class from November to last week. We've only had like 60-minute stretches in here. Now, think like 3 hours. Yeah, it's going to be great. Woo! I'm just trying to hype y'all up. It's going to be great. You're going to punch this test in the face. Math can be violent, and it should be violent. You're going to take this test by the neck and be like, screw you, AP graders. I so want to be one of them one day. Anyway, last question. I got to zoom in on this one. Here we go. I'm not going to give you any hints on this one other than reading the question itself. 4 math majors received the following salary offers upon graduation: $48,000, $55,000, $42,000, $51,000. Assuming all assumptions are met, establish a 95% confidence interval for the population mean. Oh no, I can't use my calculator to just get the interval, and I actually have to figure out what it looks like based on the structure of the formula? Yep. Okay. Couple things. First, the 49,000 is not going to help because they all start with 49,000. The 5,477, I'm assuming that is the sample standard deviation. The 5,477 is not going to help because it's all the same for all of them. Dividing by a square root. They might put in divide by the square root of 3 if that were the degrees of freedom, but that's not the degrees of freedom. It should be the sample size. So the answer has to be either one of these two, D or E. What it comes down to is determining this critical value, 2.776 or 3.182. You got to know whether it is a Z interval or a T interval. And in this case, they most likely made it a T interval, which means you would have to find the right T star to fit this scenario. Now, on your fancy calculators here, you do have an inverse t. You do have an inverse t. Now, again, there's other ways of doing this, and actually, I'm probably going to have to talk about this on Wednesday a little bit, how to do it without inverse t. I have shown you once, and I will show you again. But if I'm going to be doing this, then I believe I would be doing 0.975 for the percentile. In fact, yes, I'm going to have to revisit this question. With the degrees of freedom of 3, in order to get that proper T star, which you can see is answer E. Got to be choice E there. So yeah, we're going to revisit number 41. We're going to revisit number 41 simply because, well, we're out of time. Have fun at lunch. Don't forget your assessments. Oh, if you're in the live chat, I will leave it open just for an extra moment, only because if you haven't left a comment. I got to come back to number 41. Thank you. You too. See you guys. Bye-bye. 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 You too. Thank you. See you guys. Have a good one. You too. See you. Bye. Thank you. You too. Bye-bye. Thank you. You too. Screenshot. There we go. I got the chat. I was just screenshotting the chat. Okay, signing off.